Hello everyone, George here. In this video we're going to deal with our fan. Now I was going to mess with the UVs on this thing and export it out and do a ambient occlusion map to make this thing have some darkness around the edges where the different pieces come together. Now since the last video I did take the liberty of doing a few things. Of course, here's the outliner, bring that on out. We have a fan group encompassing everything. If we open that up, we have all the individual objects in there, properly named so that it makes all good sense. So we're just going to go ahead and grab this whole thing. Let's go to File, Send to Unity. Let's do Set Unity Project. I had to delete all of my Unity settings because everything was kind of messed up. I actually still haven't dealt with it, but I wanted to record a video, and I'm probably going to have to reinstall Maya due to some problems with Turtle not working properly, or the baking system. So let's go to, what was it called? A Night at Georgie's. That should be my directory. Please select the valid. Oh, Unreal. I want Unity. Let's go to Unity, select Unity Project, up, and go to A Night at Georgie's, select File, Unity Send Selection, and then let's go ahead and find the object. So we'll go to, let's see, Assets. Let's add a new folder, call this Fan. Go inside of there. Now there's no, there's really nothing associated with this actually. Let me take a second here. Let's right click and assign a new material. Let's use a Fong. Call that Fan _M. And you know what, just for me, let's go to modeling. Let's go to UVs, and all I want to do is just give it some form of UVs. Let's do automatic and hit apply. And of course I need the individual object selected and not the group. So let's go to Window, Outliner, grab the objects, hit apply. And at least I have some form of UVs on this object now. And now let's hit up. Hit F8 to get out of that mode. Hit up, File, Send to Unity Selection. And now let's jump down to our fan and just call this Fan. And I shouldn't need to embed anything. Nothing's really coming along, so let's hit export. I will probably come back to this and deal with things like baking to make it look proper in the future. Just for right now, it's not an option because my version of Maya is a little bit broken. Save this on out, come on down. Let's load up Unity now and see what happens. All right, here we are. We can close the animator. I'm not going to need that at the moment. We have our console, that's fine. We have everything over there. It should have loaded in the fan, and there's our fan right there. Let's bring the fan in because I'm certain that the scaling is all wrong on this object. So yes, of course it is. So let's go to the fan itself. I think it's 100. I'm off by at least. So there's our fan. Grab it and move it up and down and somewhere in there. And yes, it's about, I'd say maybe 2 to 3 times larger than it should actually be. So we're going to have to edit that as well. So going in here to our fan, let's go to our scale. Not what I wanted to do. Let's do EW and R and scale that on down. And you know what, I'm just going to put the fan in the center for right now. We'll deal with moving things around in the future. Let's just get the scripts up and running. We have no reason to have an animator, so let's remove that component. Move it on over and maybe rotate it ever so slightly. So the fan itself has all of its objects as sub-objects, so we have plenty of things to work with. Save that off really quick. So a few things we might want to do that I'm thinking of is defining a material for the blinky light right there. The knobs, the body, and everything else are probably going to be similar. So let's go to the fan. We have our materials. Let's name that from Fong 2 to something a little bit more interesting. Let's F2 and call this fan _body. Let's also create a new material. There we are. And let's just call this one fan _LED. So the fan body is already assigned to everything. Let us give it some smoothness. I'm going to keep the metallic away for now. We don't need to worry about anything else. The fan LED though, we're going to turn the smoothness, yeah, it's fine, but the albedo color on that should be red. And I'm going to assign that there. And what we'll do is modify the material on that object in our script so that as power goes out, we'll be dealing with the fan also losing its power, and of course its blades not rotating properly. We're also going to need a sound effect for this fan at some point, so I'll need to come up with something for that. I might go into the other room, do a jump cut, and record the sound of some form of a fan blowing. I don't even know if I have a fan like this, actually. All right, so let's get into the scripting for this. Let's create a new script, C# script, and as you notice, it's been a while since I've actually worked on FNAF heavily, and my method of coding has changed a little bit since then. And rather than put everything under scenes and scripts and items and whatnot, I typically now create multiple folders for each asset or item so that I can move these from project to project easier, and the overall requirements or the relationships don't matter as much. So let's just call this one a fan script. Double click it and open it up in Visual Studio. So it's been a little bit for me since I've worked on this project, and I believe I had implemented some form of an interface or some form of inheritance that dealt with objects that required energy to perform their task. So in the case of this fan, it's going to be on until the power goes out. So I need to remember how the hell I did that. So let's go to scripts, and I believe it's here. We have powered, power graphic, power manager. Let's open up powered really quick. So this is an abstract class that inherits from mono behavior. It takes a particular wattage, and on power outage, it will do something. So I believe the last time I did this coding, I had put in a slow reduction in power over time. What the fan is going to do is continuously draw power, and the fan is going to become my sink, which is why you continually lose power over time, even if you have your doors open and your lights off. So it's going to take on that role. And when the power goes out, I will implement on power outage, which will spawn a coroutine, which will slow down the fan blades to where they only rotate, they slowly stop rotating as quickly down to a velocity of 0 over several seconds. Yeah. So is there anything else I'm missing? So let's do a quick look at FNAF fan. Not fan fiction, just the fan. And also let's do more. Let's go to setting, tools. Let's see, type. Let's do animated so we can see if someone put the fan out. Okay, that's relatively simple. I was worried that the fan might have, the tinsel on it that kind of floats so that you can tell whether or not the fan is actually rotating. But that's not there, so it doesn't matter. And those are all... Someone likes the liquid effect, apparently. I have no idea. Anyway, wow. That's special. Okay, moving on. Close that and close this. Therefore, all we need to do in our script is inherit from powered, grab the game object for the rotational portion, grab the portion for the red LED as well, and create a coroutine that will, upon this implementation happening, or this being fired off, it will then slow down the fan and everything will be fine. So let's go ahead and do that. All right. So fan needs to implement powered, so let's do that. So fan is a subclass of powered. Fan does not implement the abstract class. Thank you, thank you, thank you. Geez, I've been doing a lot of Android programming, and let's implement that abstract class. There, it added the override for the on power outage. We can get rid of the throw command because it is implemented, and we're fine there. So on power outage, we're going to want to start a coroutine that I have not created yet. But before I jump the gun, let's grab references to the objects we're going to require. This script will be attached to the topmost element of the fan. We are going to need to get access to the child elements. While I could search for the child elements, it's just going to be easier for me to do a game object fan blade and a game object. What's the other one called? Fan blade and LED light. We can make these public if we want to, or we can do serializable. Not serializable. looking at the Unity documentation, which is something you should always do when you have questions, it is the serialize field attribute. So let's do serialize and field. There it is. Now we can show that variable without making it public there as well. Let's go over to here, grab our fan and apply our fan script to the fan. Wonderful. There's our fan, our two game objects. We are going to grab the, now here's a good question. Where's the pivot point on our fan? Let's grab blades, hit W. The good news is it looks like it's centered properly, so that's not a problem. Okay, so blades can go to fan blade, and then LED 01 will then go to LED light. Wattage. Now I'm remembering wattage was how much it drains per second. So let's do 0.5 at the moment. Save this on out. I am going to need to adjust the script that handles it, which is the wattage manager. So let's go to light, use manager, time manager. There should be an energy manager, power manager. Let's open up the power manager. Here's our power sync, which now is going to be 0. The power sync no longer matters. Yeah, so that's this line right here, because the other object will continually be pulling stuff from it. This is technically useless, but I'm going to leave it for now because I'm not quite sure the ramifications of deleting it. Let's go back into our fan script though and begin working with that. All right, save, yes, come back here. Let's go to our fan. We can see the two fields, all is good. They're set up. On start, what do we need to do? Well, we're going to need to continually rotate our fans over time until we get this power outage notification right here. We can start a coroutine, which will continually rotate that fan, or we can just do it in on update. And we can create a Boolean value that will then stop update from doing whatever it's supposed to be doing. So let's just do, actually, within the powered. So we have a wattage. What we don't have a value on whether it's currently powered. That might be something I should add to that subclass, but let's just do it here for now. So let's do bool in C#, not Boolean. Bool is powered equals to true. Great. So now that it's powered, we can go into update and we can do is powered. If is powered, we're going to continually rotate this thing. Is powered. And we'll do something there in a second. But more importantly, when an on power outage occurs, we want is powered to equal false. And then at this point, we're going to start a coroutine. Start coroutine, which will be, let's do, what is it? Enumerator, power down. Oh, we're in C# land, so we need to do capitals, power down fan. And what I'm expecting to do when we power down the fan is, let's see. First, slow down spinning speed. And then the second thing is going to be also slowly decrease intensity of the LED, which might become the shader's ambient portion for that. Well, I don't know, I'll figure it out. So anyway, right now this is not returning a enumerator, which is why I'm getting an error there. We are going to need some form of a while loop though. So let's do while something happens, and we're going to grab these because this is what's going to continually happen within the while loop. That's how coroutines work. So we launch the coroutine and then we do something for a period of time, and it's up to us to continually indicate that, continually make changes. So let's do while whatever, we'll figure that out in a second. Let's do a yield return null, which means we'll move to the next frame. And when we're dealing with animations, we want to make sure it's frame by frame for the most part. Okay, so while is powered, we're going to want to rotate the fan blade bit by bit. For that, we're going to, of course, want the transform. So let's do fanblade.transform.rotate. I don't know which direction I want it to rotate in yet. Let's hit, wow, wrong IDE. Control P is not the proper one. What is it? Let's see. Control, Shift, and Space. Let's try that. Control, Shift, Space. Does it. Okay. So we want to rotate around a vector 3. We also have an axis, an X and a Y and a Z axis, which we can do, which is just probably easier. So let's go back to our fan, take a look at it really quick, and gauge. It looks, oh, you know what? That's global, right? Okay, good. Local. Locally, it looks like we're going to be rotating around our Z axis. So that's where we're going to want to do all these rotations. So what is it? Control, Shift, Space. And let's go to, let's just do that. This one. So it's going to be 0.0f, 0.0f, and then finally some quantity that we're going to rotate by. So we should probably have a blade speed, because I like dealing with velocities and accelerations as opposed to absolute positional changes. So let's do a serializable or serialized field, and let's do a float fan blade speed. And we'll give that a default value of, let's see, this is degrees or radians, I don't know. It's one of them. Let's just do 5.0 to begin with. That's probably too low, so I'm going to go ahead and increment that to 15. Grab the fan blade speed, come on down. And in here, we're going to take fan blade speed and multiply that by time.delta time. Since this is a speed or speed or velocity, really it's this part's a speed, but the entire thing together could be considered a velocity with direction. The fan blade speed times time means we have an absolute amount of positional rotation that we incur over that period of time, which is delta time. That being said, that will now rotate so long as it's powered. Yeah, okay. So that's fine. And this is fine. This stuff is going to be causing some problems. So let's go ahead and start that coroutine. Coroutines can be handled in two different ways, of course. We can either call them directly, which we can do because we have no parameters, or we can specify the string or the name of the function that we want to work with for this particular game object, and that will also work. I'm just going to call the coroutine directly, so we'll do power down fan. There we are. All right. So, wow. Okay, you know what's a problem? Okay, I'm getting some errors already. I actually don't have any of my Vive stuff set up. So while fan blade speed is greater than 0.0f, that's not where I should have written that. So when this happens, we're also going to want to decrease the fan blade speed a little bit slowly over time. So let's do fan blade speed minus equals some proportion of the total. So we'll take the initial fan blade speed, which we'll define up here. So we'll do float initial fan blade speed is equal to fan blade speed. And what we want to do is float increment is equal to fan is equal to the initial, if I could spell, initial fan blade speed divided by some quantity of time. Let's do, I don't know, 5 seconds, something like that, 5 units. So that's going to happen there. This is how much we're incrementing over that period of time. So then we will need to do fan blade speed minus the increment times time.delta time, I believe. Because time.delta time is a small number, dividing this value by another unit of time is going to provide us with units of what? It's distance or rotation divided by time. We then divide that again by another form of time. Division is the same as multiplying by 1 over that, so that's the same as acceleration at this point. So to get this back down to time, velocity change, we need to multiply that by time.delta time, which is what I'm doing here, which will then change the speed giving us our new velocity for the spinning of this thing. We're not going to worry about the LED just yet. Let's get the spinning stuff down. So then we're going to be utilizing this fanblade.transform.rotate stuff up here. So fanblade.transform.rotate, la 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 la, all is good. And all we need to do is, since we are directly modifying the fan blade speed here until it hits 0, this should be fine. So that's good, that's good. We might have a case where we end up reducing this below 0 that I might have to check for so the fan doesn't go in the reverse direction. We'll deal with that when we come to it. Anyway, so let's give it a go. Coming back over here into the game, all of our errors are gone. I do not currently have my Vive set up in any way, shape, or form, so I might need to do a short jump cut to get that stuff to work. In fact, I think, you know what? That's a good enough video for now. We will pick up from this in the next video and do the LED after this. And by then I will have had my Vive set up. The reason I'm not doing that right now is because it's notorious that my system will potentially crash my recording software and everything else associated with it as soon as I start changing things like the Vive HDMI ports and everything else associated with it. So for right now, I hope you enjoyed this video. In the next one, we'll have that fan up and working, and hopefully we're going to move towards some more interesting elements of our finalized FNAF game. Thanks, everyone. Thank you, everyone. If you enjoyed this series, remember, subscribe, like, all that good stuff, just so that I know you're still interested in it, and I will continue to produce content. Have a great night, everyone. So long. Bye.